In this video here, we're going to do visual similarity search with OpenAI's CLIP model and Meta's FAISS, which is basically just for search. So semantic search, how do we search across images, both with natural language, but also how do we convert our images into representation that can be understood and also matched with the text that we're doing our search for. So if you just jump straight into the Ultralytics documentation, we've created this new similarity search solution. So this is brand new. Definitely go in and check it out and also test it out because we can do something very awesome here. So when we're talking about semantic search, image search and so on, we need to actually have matching and corresponding image pairs with text pairs, and this is where OpenAI's models comes in. CLIP model is basically just a large scale model trained on images with a description. So this is basically just like corresponding pairs. Then we actually just convert our images into embeddings as well. So it needs to be in the same space because we need to have them in the same space before we can do our similarity search. Often when we do similarity search, it's just the cosine distance between two vectors and so on. So this is also a very efficient search method and very nice if you want to go through a ton of data. Let's say that you have a data set with hundreds, if not thousands of images. It will take very long to go through, search through and so on, instead of just having a visual interface or a visual prompt where you can specify what exactly are you looking for in your images. And there's no way for the model to understand what's actually going on in the image unless we have a visual description, so a text description of it converted into vector embeddings, because again, models, AI models and so on, math, it doesn't work with sentences, so we need to convert those sentences into vectors of floating point values. So we basically just have two n-dimensional vectors that we do similarity search for. We calculate the cosine distance between them. There's also other different distances, but this is very efficient and it makes your data sets way easier to go through. Could be used for finding edge cases, find specific situations and so on that you want to pull up. We can also see like an example here: sofa, bed, chair, table, curtain. Then it's basically just going to search for those and pull those up. So CLIP model here uses a vision encoder, so a ResNet or vision transformer for images, and also a text encoder. So that could be a transformer based text encoder, but the most important thing here is to convert them into the same space so they can be matched. So this is the same for multi-model embedding spaces, and we can see this allows direct comparison between text and images using cosine similarity, so what I also already mentioned before. Then another one here is the FAISS. This is Facebook AI similarity search. So it's basically just going to build out a structure with an index for our image embeddings, and that enables faster, more scalable retrieval. If you scale it to tons of different vector embeddings, tons of images, like hundreds or even thousands, tens of thousands of images and so on, if you need to go through every single example and so on, it's also good to build out a knowledge graph and all that. But there's these methods here, for example, developed by Facebook AI, that just makes it way faster to pull up all this information to retrieve the closest vector for a given query. You also can see here Flask, it provides a simple web interface to submit natural language queries and also display semantically matched images from that index. So it's using indexing and then it's using similarity search after that to basically just narrow down what we're searching for. So we see with the Ultralytics solutions, we have this search app. We need to build out our data set pretty much. So we need to build a search engine with our data. We just need to throw in our directory for our images, specify the device, so we can either use CPU or GPU. If you can use GPU, that's preferable. It's just gonna make it way faster, and then we can run our app here. We can also build out similarity search or similar image index. So with the new solutions tab, we have this search app, but we also have a visual AI search where it's basically just in the background, it loads and builds the FAISS index from local images. It extracts the image and text embeddings using the OpenAI CLIP model, and then it does the similarity search across it. So for example, this one up here is basically just going to run our search app with the Flask, as we mentioned up here at the top, but we can also run it directly just under the hood and do our similarity search with our ranked results. So the higher similarity score, the better match we have with our prompt. So this is our query that we throw into our system, a dog sitting on a bench. We have this searcher. Then it's going to take that prompt, convert it into vector embeddings. So it's going to convert it into a text embedding, and then it takes that text embedding, matches it with Facebook AI search with the indexing as well, and then it goes through all the images that you have in your data set, calculates the similarity score of it, and then it comes up with these ranked results. Right now we can see the top 5. So these are some of the parameters. We basically just need to specify our data set and our device. Here's some of the advantages of semantic search for like using CLIP and FAISS. Zero-shot capabilities. We can snipe down exactly what we need to look for in our data set. Human-like understanding, this is how humans would understand it as well, but it can go through significantly more data than a human and basically just pull it up to you based on the similarity score. So no need for labels or metadata. This works on raw images because the CLIP model is just trained on a large amount of data with corresponding text and image pairs. So it could be trained on a child playing soccer, then we have these images. This is one image pair or text image pair. CLIP is trained on hundreds of thousands of those examples. Flexible and scalable search. So we have our images, we have our encoder, we have our indexing with the Facebook AI search, semantic search, and then we have our embedding vectors. So this is the vectors that is actually going to do this cosine similarity distance between to calculate the score. This could also be used for cross-domain applications. So if you have different domains, could be your personal photos here, for example, could be anything where cross-domain, where you have 2 different areas. You have completed two different data sets. You have some production and you have some cat and dog images. That could be 2 domain applications, and you can just pull the images from both domains, basically just by querying with your text prompt. This is very useful in a ton of different computer vision applications, but also just in any application out there. For example, you can use the exact same with Netflix, YouTube, anything. All these large companies, they also use exactly this, where, for example, come up with search, like if you were searching for in Netflix for a movie that you want to watch, you throw in the query, it's basically just going to do similarity search on tons of different examples out there. They actually have the metadata in the background with the details about the movie and so on, and then they basically just match it with that. But that's also one example. Tons of different examples out there. Let's try to see if we can actually run this. So right now, I'm just going to open up my IDE. Let's open up a new window. Let's grab this one here. So now we're just starting all the way from scratch. Let's go create a new file. So let's call it search.py. There we go. That's all we need. And we have it down here at the bottom. Let's clear it, make it a bit bigger so you guys can see what's going on. So we'll try to grab this data set here. All we need to do is basically just go down here and grab the download URL. Let's throw it in here. It's gonna download a zip folder to my computer. We can go back into my editor. Now I'm just going to grab this over. Now we opened it all. So now we can basically just take this folder that I downloaded. I'm going to drag it over here and copy the folder. So we have our Coco 8 with our images. We have a train and validation. Right now, let's just put everything up in the training set. There we go. We can grab the path to our images. So let's just copy the whole path. We go inside our search. So let's go inside and grab the actual example. We're just going to run it on CPU for now. There we go. This is the code example that we need. And we need to specify data. This is the only 2 arguments that it takes. So let's grab the full path. So just copy that one. There we go. Ultralytics Solutions, Python. Let's go down and clear it. And now we should be able to run our search. See, we got an error. We need a comma here. There we go. Search.py. Let's see what we get as output. Might go in and download. So it has no attribute. If you get this error here, make sure that you go in and pip install it. I'm just working in base environment right now. So make sure that you go in and upgrade Ultralytics. There we go, it's now updated, and we should be able to run our search now. So we see that this is not found. It's automatically going to go in and download the FAISS. There we go. Now we can see that our Flask application is running locally. We can open it up. Semantic search, image search with AI. Well, let's take a look at the logs here to see if it actually got it right. So it indexed 8 images. This was very fast. So it's building the FAISS index from the images. We have the indexing up and running, so we should be good now. Now we go in here and describe the scene. I don't even know what's in our data set. So we have a zebra, we have some other different animals here. So let's just try to see, show me animals. Let's search for it. There we go. Now we can basically see that we get these similarities. And again, now it's showing more images than it should, but it's actually like just sorting it here based on similarity search. Maybe there's a threshold somewhere how many images we want to show. So we can see the first 4 ones have higher confidence score, even the 5th one as well. So you can see that these ones here are the actual like animal images. Right now, let's try to go in and search for zebra was the first one, so we can maybe go in and search for horse. Try to see if that gets ranked first then. Just search for horse maybe. Maybe the zebra will be second. Yeah, so it even sees the zebra as a horse as well, basically just for the similarity. So these are the significantly highest similarity scores with the zebra and also these 2 horses. So let's try to see, show me 2 horses. Let's try to see if we can get these horses first. And now we can see that actually just swapped it around. And now we have the 2 horses first. Because this might have a description, 2 horses with 2 men riding, or 2 men riding on 2 horses. This could act like be the corresponding text pair that has then been inside or embedded into the embedding space, and then we do our similarity search. So this is pretty awesome. Definitely go in and check it out. Like, you can search through tons of different data. You can see how fast it actually like went in and indexed my images. Test it out on a small data set like I did here. You can see I set everything up from scratch pretty much. This is how easy it is. You can use larger data sets. Very helpful when you deal with data that you just want to search for. But it's also just a cool application and feature to show people, because a lot of the AI models, large language models, RAG-based systems, computer vision systems with videos, images, and all that is actually like based on similarity search. Make sure that you understand what's going on here and so on. Test it out. It's so cool to play around with, and this is like the new stuff within AI and computer vision. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy learning.